Okay, Dave, can you hear us?
Yes, can hear you. Can you hear me?
A lovely introduction, and now we're ready for you to kick off. If you want to just let me know when you want to change slides. And
Okay, so have you had the introduction already?
We have, yeah.
Oh, okay. I didn't hear any of it.
Yeah, do you mind to, we can again.
Oh, I could do the introduction if you would. I can do the introduction. Yeah, all right. So welcome to everybody online. We've got three speakers here today to talk about the tipping points report. The first one is David Armstrong Mackay, who'll be talking about the climate tipping points. The second one is myself, Josh Buxton, and I'll be talking about impacts of climate tipping points. And then we have Steve Smith, who'll be talking about positive tipping points. So to start us off, there's Dave Mackay. Dave, just let me know when you want to change the slides.
Yeah, go for it. Can you hear me in the room?
We can, loud and
great. All right, change slides, please.
there we go.
Cool. So yeah, back in December, during the COP, we launched this global tipping points report, which was after a year's worth of work, pulling across scholars from across both Earth system science, but also from governance and emerging research around positive tipping points as well, to give a comprehensive summary of the state of tipping points as we stand in 2023. This is one of the, just going to go through a bit of a quick overview of what sort of things we covered. So we started from a position of looking at harmful, negative tipping points, particularly ones in the biophysical Earth system and how those would impact people, particularly the negative, harmful impacts they would have on societies. Next slide. We also looked at some of the governance issues around how we try and prevent those tipping points from happening, and also how we might adapt and deal with those tipping points if they do happen, the impacts on societies and how there could be ways of trying to mitigate those tipping points in the first place, and whether that has implications for loss and damage and things like that. Next slide. And finally, there was a section in the report that was specifically dealing with positive tipping points, this idea that there could be socioeconomic and social tipping points that could help try and reduce emissions faster, to decarbonize more quickly, in order to try and prevent some of these more negative Earth system tipping points from happening in the first place. Next slide. And we came up with these key recommendations overall for the entire report. Obviously, the headline, and this reflects across all the various different other work that goes into the COP as well, that we should phase out fossil fuels and land emissions as soon as possible. We should also be strengthening adaptation and loss of damage governance as well, particularly in light of tipping points. We should be thinking about tipping points in the NDCs from the different countries and the global stock take, so basically bringing tipping points into the UNFCCC COP process. We should be coordinating policy efforts to try and trigger some of these positive tipping points as well, I just mentioned. There should be a summit on tipping points, potentially convened by the United Nations, in order to discuss them in more detail. And also that we should try and continue to do further research in order to deepen our knowledge of how tipping points actually work and how we can actually translate some of these ideas into action. So next slide. This is a schematic that sort of summarizes some of those points already. That bottom black curve that shows a sort of negative pathway, as if you will, of going through Earth system tipping points and then have negative tipping point impacts that cascade through into societies. So that's kind of the pathway we want to avoid. Whereas the top pathway, the blue one, is one where we try and reach positive tipping points in society and economy and technologies that try and prevent some of these tipping points from happening and bring us up onto a more desirable pathway. And in between those pathways, we have governance, the things that help us try and mitigate better and also adapt if we do hit some of these tipping points anyway. Next slide. So yeah, I led, along with Sina Loriani at the Potsdam Institute, the section on Earth system tipping points. This is covering kind of the biophysical background. It's kind of a bit parallel to the working group 1 of the IPCC reports. So it's looking at the biophysical side of things. Next slide. So yeah, this is the first section of the report, section 1. There are further sections specifically on the societal impacts of tipping points, then the governance of those Earth system tipping points before we move into the positive tipping points as well. Next slide. So yeah, to start off with on the biophysical side of things, we know that the Earth system is under pressure. This is a cartoon showing different parts of the Earth system that we split into the cryosphere, the icebound parts of the planet like sea ice, permafrost, ice sheets, glaciers. We have the biosphere, the global sum of all ecosystems, so forests and temperate, tropical and boreal zones, drylands and savannas and grasslands as well, and then marine ecosystems too. And then in the ocean and atmosphere, we have various circulations in the overturning circulation in the ocean, but we also have things like monsoon systems and the jet stream and things like this. We know that human activities are already having major substantial impacts on all of these systems, particularly through climate change, but also through in the biosphere, things like habitat loss, over exploitation, pollution as well. And pollution as well can, to a certain extent, affect some of the atmospheric circulation for things like monsoons as well. So we know that there's human pressure already on all of these systems. Normally, we would expect that there's a fairly linear relationship between the level of pressure and the level of impact. So you might say, expect that double the pressure on a system, you get double the measurable impact. But we also know that there's lots of non-linear change possible in the Earth system. Next slide. So one particular type of nonlinear change that we're interested in this report is tipping points. So here we have our definition for Earth system tipping points. Tipping points in our definition occur when change in some system, which we call a tipping system or a tipping element, that change becomes self-sustaining, self-propelling once some threshold in the level of pressure the system is under is passed. And then this leads to a qualitative state change, so a complete shift in that system state that is driven by a set of positive or amplifying feedback loops. In the bottom of this slide, we have a figure, a schematic showing one of these particular positive feedback loops as an example, looking at ice sheets. So with global warming, the local warming over an ice sheet is increasing, for example, the Greenland ice sheet. This is leading to greater surface melt. That means that the ice sheet is losing height. As it's losing height, it's dropping down into warmer air because in lower altitudes, the air is warmer, so the inverse of climbing a mountain where it gets colder. So as the ice sheet falls into warmer air, that helps to amplify the local temperature over the ice sheet, which leads to more warming. So this, in effect, amplifies the amount of warming and melting you get on an ice sheet as it loses mass. Initially, as we can see on the right-hand side here, when the ice sheet is higher, it's a relatively small amplification, a little orange arrow on top of the red arrow. But once you pass a certain threshold, that amplification becomes strong enough that it becomes self-sustaining. So it would keep on, it reaches an altitude where it's warm enough that that melt will keep on going and the ice sheet will keep on losing mass, even if the global warming original driver stops. And this is the point where the change becomes self-sustaining, even if the original driver is removed. And this is what we refer to as a tipping point. Next slide. So based on reviewing the literature, scientific literature covering ancient climate records, paleoclimate records, computer model simulations, theoretical work, and more observational records as well, we identify over 25 Earth system tipping points from the scientific literature in this report. And this is a map showing them. I won't go through each of these in this particular map. We'll go through each of the different parts of the Earth system in turn. But you can see that they pretty much cover all of the Earth's surface, so they are relevant for everyone. Next slide. So going through in the cryosphere, just as a guide to how to understand this map, the plus signs mean where we have, we think there is evidence for tipping points in that particular system. Minus signs mean where we think there probably isn't evidence for tipping points. And a number of those symbols shows our level of confidence. So 3 plus lines, for example, means that we have high confidence that there is tipping dynamics in the Greenland ice sheet, the West Antarctic ice sheet, and the marine basins in East Antarctica. And we have medium confidence that there's also tipping dynamics in the non-marine parts of the East Antarctic ice sheet, and also locally and regionally in mountain glacier systems and in land-based permafrost as well. Whereas in contrast, we have fairly high confidence that there is not a tipping point in Arctic summer sea ice, probably not also in Arctic winter sea ice or in subsea permafrost, or permafrost and glaciers on land at a global scale. And there's uncertainty around the Antarctic sea ice as well. Next slide. In the biosphere, we have good, decent evidence across lots of different types of biomes and ecosystems that there is potential tipping dynamics. So, for example, we have evidence of potential forest dieback in the Amazon rainforest and the boreal forest, where things like we're already seeing a localized and regional coral reef die-off in the ocean. Also included in this report for the first time, things like looking at savannas and grasslands and some of those other different biomes which aren't just forests. The evidence is a bit more complicated than for the cryosphere, though, because there's multiple different drivers for biosphere change. So it's not just climate change. We have habitat loss, deforestation is important, particularly in, for example, in the Amazon. We have nutrient pollution, for example, pushing lots of lakes towards local eutrophication tipping points. So the story's a bit more complicated, but we definitely find a lot of evidence for tipping dynamics in the biosphere in this report. Next slide. In ocean and atmospheric circulations, there is medium confidence in there being tipping dynamics in various ocean overturning circulations. So, for example, the well-known AMOC, the Atlantic Meridional Overturning Circulation, running down the middle of the Atlantic there, but also the subpolar gyre, which is effectively a side branch of the AMOC in the North Atlantic there. And also in this report, we spent a bit more time on the Southern Ocean overturning circulation as well, so around the coast of Antarctica. That's something that we give a bit more attention on. Same actually with the Southern Ocean sea ice in the cryosphere chapter. There's medium confidence in this report that there is tipping dynamics in that circulation. In the atmosphere, things are a bit more uncertain. So in general, there's some evidence maybe for tipping dynamics in the West Africa monsoon, but uncertain around the Indian summer monsoon and the South American monsoon. And probably not tipping dynamics in the El Nino Southern Oscillation there, or in the jet stream you can see in the Northern Hemisphere, or in the link between tropical clouds and circulation. Next slide. These Earth system tipping points are being destabilized, and some may be close. So here we've grouped some of the different drivers together. You can see climate change on the left is a key driver that's shown by the larger symbol for across pretty much all of the different categories of tipping points we're looking at. And some of those have exclamation marks showing that they could be approaching tipping points because of that driver, in this case, climate change. But also, particularly for the biosphere systems here, we have habitat loss and shifts, pest and disease, pollution, and exploitation as well, that are primary drivers for potential tipping in those systems. And some of those are approaching their potential thresholds, for example, in the Amazon rainforest with habitat loss and exploitation, or with lake eutrophication and nutrient pollution. Next slide. We also look a bit, we have a chapter looking particularly at the interactions, here specifically climate tipping points, and whether they tend to stabilize or destabilize each other when you consider them as a system with interacting dynamics between them. In this map, this is a review of the interactions between some of the systems and some of the things that are probably not tipping systems but still interact closely, like Arctic sea ice or El Nino. The red arrow show destabilizing interactions, and the blue arrow shows stabilizing interactions. And overall, most of the interactions were found to be destabilizing. So that means that if one tipping system tips, the ones that are connected to it become less stable as a result. This raises the possibility of something called a tipping cascade, where if one tipping system tips, it causes another to tip, and so on. There's not a huge amount of research yet around this, apart from to suggest that it's possible, but there's not a huge amount of evidence to suggest that it is likely. But the trouble is that we are approaching the sort of warming levels where some of the key potential initiators of such tipping cascades, they're starting to become more likely, or at least possible. So it's definitely an area of research that needs to have a lot more attention on to do a risk assessment of what the issues are here. Next slide. And our final chapter was looking at early warning signals that could potentially precede Earth system tipping points. The idea here is that if we look on the right-hand side, this schematic, in a sort of classic ball and valley schematic here at the top, in the blue one, the ball is relatively stable because it's in a deep valley. And you can kind of use statistical analysis of data from this ball to tell that it's relatively stable. The variability on that ball is relatively low variability, and the variability is quite sort of fast. It sort of wobbles quite quickly. But as the ball becomes less stable, as that valley is becoming shallower, which makes it easier for the ball to roll out of the valley, the ball's behavior becomes more erratic. You can see that in the red data there on the right-hand side. And you can use various things like variance or autocorrelation in that data to give you an understanding of whether that ball, whether that system represented by the ball is more or less stable over time. When applied to various records and data and observational data from the Earth system, on the left-hand side here, we have a map showing different parts of the Earth system that could be proposed as tipping systems, and whether they have positive early warning signals based on a sort of method or negative. The red showing positive ones, and you can see that there are quite a few parts of the Earth system that are suggesting this sort of early warning signal that will be consistent with them approaching tipping points. However, it's a bit unclear because it doesn't always necessarily mean a tipping point is approaching. It can just be losing in general. But there's enough information here to suggest that it could be some approaching destabilization, and this is another area of important research. Next slide. And yeah, so on the basis of this, for our section, we make various recommendations. We want to prevent the destabilization of Earth's tipping systems through urgent climate mitigation, but also reducing other pressures critically as well, such as deforestation or black carbon emissions, nutrient pollution, stuff like that. We want more research to reduce some of the deep uncertainties, particular processes suggested here in models that we could really get a better hold on, and include in models to get some of these dynamics better represented. Risk assessments for potential tipping cascades, again through better models, but also some other approaches as well. And trying to develop and improve some of these early warning techniques, for example, using machine learning methodology to try and advance those forward as well. So I will now hand over to Josh for section 2.
Excellent. Thank you very much, Dave. So I'm Josh Buxton. I'll be presenting on the tipping points impact section, which was led by Jesse Abrams. So this section is concerned with the societal impacts of tipping points and also potential negative social tipping points. So we'll talk about impacts on people of Earth system tipping points, which is a chapter that was led by Rich Betts at the front here. We'll talk about negative social tipping points, cascades of tipping points and impacts, and then also potential early warning signals of impacts of tipping points. So, kind of the conclusions that we came to is that this is kind of the sort of smaller, under-researched brother of climate tipping points, whereby there's little systematic assessment of tipping point impacts out there in the literature. In some places there's kind of qualitative analysis, but there's not too much in the way of solid quantitative analysis. It's a case that tipping points of these systems will have additional impacts to if the systems just change linearly over a longer time period, whereby you may have greater hazard because you haven't been able to adapt as quickly. It's happened before you expected it, and then some of these tipping points will lead to an acceleration of climate change. So, we have some examples here whereby we have the AMOC collapse, in the Earth system, will then have an impact on regional climate shifts. And, in terms of human societies, this will then impact on agricultural production and undermine efforts to combat climate change. And similarly, on a different timescale, ice sheet collapse will lead to sea level rise and the destruction of coastal infrastructure, and then migration. So to give a few more of these examples, Amazon dieback will potentially lead to 6 million people dying of heat stress, and in excess of $1 trillion up to perhaps $3.5 trillion of economic damage. And that is ignoring the biodiversity impacts of Amazon dieback. Antarctic ice sheet has impacts across water security, food security, energy security, health, biodiversity, and communities and economies, and has the potential to increase sea rise by 2 meters by 2100, which would expose nearly 500 million people to annual coastal flooding events. Permafrost thawing, will impact local communities. As Dave was saying, the impact globally is currently uncertain. And an AMOC collapse would lead to substantial disruption, especially in the northern hemisphere in terms of food security. And for example, in the UK, you'd be looking at the loss of most arable agriculture with the changing climate that you would see for that. But essentially, all of these tipping points have impacts across all of these different sectors, and it is all interlinked at different timescales. But in terms of the actual research on this, I think we found that there was a lot of gaps in the literature, and that there's a lot more assessments that would need to be done. Potentially, you could envisage country by country assessments for each tipping point, but we need to be conscious of timescales as well. So negative social tipping points. So these are social tipping points that are predominantly harmful for humans and the natural system that we depend on. And negative here being in terms of value rather than mathematical. And these, we were conceiving that these could be caused either by linear climate change or tipping points in the Earth system. And so for these, the authors identified several sets of tipping elements. So we might have social psychological systems, where we may see an increase in radicalization and polarization with climate change, as well as with other drivers. You may see an increase in displacement and conflict and financial crisis. And obviously, all of these tipping elements interlink with each other. You could conceive of how displacement might lead to more conflict or might lead to polarization. And obviously, all of these tipping elements kind of exist across different spatial scales and temporal scales. Some of them are incredibly localized, others might have more global dimensions, such as an economic crisis. But they also not only interact on other social elements, but they then feed back into the climate system. So if you have a society that is facing some underlying social issues, it may be less likely that people can engage with and target the climate crisis, which can then feed back more into people facing more problems. So one example that the authors considered was anomie, which is the breakdown of social norms, and they identified numerous cases in the literature whereby environmental events, climate-linked environmental events, led to an increase in people suffering from depression and PTSD. And these are following a broad array of things, hurricanes, crop failures, flooding events. And the fear is that if you have widespread displacement of communities, you have the destruction of support networks, and then this might lead to reinforcing feedbacks whereby people are less able to cope with the change that they're facing. Onto cascades. Dave did a good job of illustrating the potential cascades in the climate system. And here, this is kind of building on the last chapter of considering systematic risk and how you may have cascades across multiple systems, but once again, the literature on this is underdeveloped. So the authors of this chapter identified several different potential examples for this and considered how you might map out some of these intersecting issues, such as Amazon forest dieback, coral reefs, forced migration, the Irish Spring and Lake Chad. And here is a feedback loop for the Lake Chad, the shrinkage of the Lake Chad. And here we have natural components in blue, so reduced inflow leading to the shrinkage of Lake Chad and changes in carbon sequestration as a result. And then social components whereby people are less able to fish, and this reinforces poverty, which can then reinforce displacement. And so there's some thought given to how some of these environmental and social changes will feed back into each other, and how we might map out potentially critical nodes that could lead to issues further down these chains. And then once again onto early warning signals. So Dave gave a good overview of how you might be able to detect transitions or tipping points or with some of these statistical signals. And a lot of the research in this is based on natural systems. But the authors here were considering how you might consider interconnected social and environmental systems and try and use these early warning signals to help with predictability. There's limited research in this space so far, which is a theme for this section. But one case study identified trends in environmental data, of this sort of 3 to 6 months prior to food insecurity events. It was suggested that further work is required to identify more case studies and data and to work out how, if these methods prove fruitful, how you might integrate them into decision-making systems. And this is this example in Northeast Kenya, whereby for a soil moisture data set, they came up with this this coefficient, which is based on the autocorrelation and another statistical value, but whereby for between 3 and 6 months before you start to see food insecurity, the autocorrelation in the soil moisture goes up and sort of stays up until you cross this transition. So kind of to summarize, the current state of knowledge is that Earth system tipping points have the potential for severe impacts on people and biodiversity, and we need to think about these impacts across many different systems rather than just localized or simplistic, like with simple models. Negative social tipping points are potentially possible between social systems, but these can also feed back into environmental systems. And that potentially there's possibilities to engage in early warning analysis of these tipping points. The recommendations for this section were along risk assessments, adaptation plans that should give deeper consideration to the implications of tipping points. And as I was discussing, there's large knowledge gaps in the literature around the impact of tipping points, such as regional impacts, and then also interlinkages between different systems. Now I'm going to hand over to Steve Smith, who's hopefully going to give us a more positive view. Thank you.
Okay, so section one covered the Earth system tipping points, and the section two looked at the impacts on people and which could trigger negative social tipping points. And so now we come to the third section, not quite the good news yet, I'm afraid. So this section was authored by Manjana Milkerit from the University of Oslo, and about 20 authors, both natural and social scientists. And it covers a really vital topic, which is very underdeveloped and hasn't received anything like the attention it should do, which is governance of Earth systems and learning how we can prevent or adapt to these risks. So there are 4 chapters in this section, beginning with the general introduction for the governance principles, the main actors, and the institutions involved. 3.2 addresses how we can prevent tipping points, and then we go into impact governance in 3.3, and the final chapter addresses knowledge and the science policy interface. So the key messages of Thank you. The key messages highlight the fact that we desperately need decision making at all levels, all kinds, to start taking these tipping points seriously. The decisions that we make in the next 10 to 15 years are going to have profound impacts on the next 10 to 15,000 years. So we really need to prevent tipping points for a start. That's the biggest priority, but also our institutions just aren't set up for that, and neither are they set up for understanding how we adapt to the impacts that we can't prevent. And just to give you 3 examples, how do I do this? Forwards. Gave me another machine there.
If you just hit that one.
All right. So just to give you 3 examples of warm water coral reefs, which you heard about in the first section, Amazon forest dieback, and the Greenland ice sheet. These tipping points unfold over very different temporal, from very different timescales. So the coral reefs in just a matter of years from now, whereas the ice sheets will melt over centuries. And then you need to contrast that with the timescales of election cycles and infrastructural projects and international institutions. And that's a fairly good way of illustrating the fact that the policy making that we have is currently woefully inadequate to deal with the scale and the temporal scale and diversity of these tipping point threats. So now is the time for governance to really step up and engage with this whole tipping points concept, and to rapidly mitigate greenhouse gas emissions, keep fossil fuels in the ground, and include tipping points. We need to include them in the global stocktake, in the nationally determined contributions, and to think about adaptation, loss and damage, and finance, collective governance, and better research and translation of that research into policy and action. So in all those areas, we're really lacking on the governance front. Now we get to the good news. So section 4, and this one was written by 56 authors, including Tom Powell, Caroline Zim, Emma Bailey, and myself, and a number of very brilliant chapter leads you see at the bottom of this slide, among others. So this section deals with the opportunities for positive tipping points. And we define these sort of quite similarly to the way that we define Earth system tipping points and Earth system tipping impacts, but these are tipping points that work in our favor. So they're the opposite. These are things we want to promote, not prevent, because they can help us avoid these negative ones and accelerate us into a post-carbon safe, sustainable future. So beyond the introduction, we looked at a brand new kind of conceptual framework for thinking about and acting on positive tipping points. It's a very new field, really, as opposed to the natural systems. We're looking at a very new field that's only a few years old. 4.3 looks at a series of case studies, and we used energy, transport and mobility, and food and agricultural systems as our particular case studies, which I don't really have time to get into now because we need to do some questions, but we carry on after that looking at the different, in chapter 4.4, the enabling conditions and interventions that we can use in any sector, across all sectors, which can themselves also have tipping points. We'll go a little bit into that, the cross-cutting enablers, 4.4. 4.5 reintroduces this idea of cascades, but in this section, it's about positive tipping cascades that can act like a domino effect of beneficially transforming multiple systems. And finally, we've got a very important chapter on risks, equity, and justice in the governance of positive tipping points. So some of the key messages are that with the right enabling interventions, the right conditions, transformative and just positive tipping points can emerge. Changes in behaviors and values and worldviews are just as important, though, as changes in technology. We tend to focus on technology because we've got lots of data and it's kind of the easiest to quantify, but we also have to think about these non-material potential tipping points in social norms and values and so on. And when we design ways to intervene in these human social systems, the avoid, shift, improve framework is often quite a useful one to use. So this is the idea that the best thing you can do is avoid using something in the first place, right? And then you don't have any impacts in the first place. If you can't avoid it, then you could possibly shift to a better product or service. If there isn't a better product or service, you can perhaps improve the one you have. So we use that as a kind of a sequence of types of interventions. But we constantly have to ask ourselves, positive for whom? Who benefits from positive tipping points? The millions of workers in the fossil fuel industry might not think of it as a positive thing initially. Some of the workforce, some of them who work in appalling conditions in the new cobalt and lithium mines, who are going to provide the materials for the new batteries, they might not sometimes think of this transformation as a necessarily a totally positive thing. So you have to think about various issues of power and governance and equity and justice, particularly when we think about marginalized voices. So the thing that binds this whole report together into a global tipping points report is this idea that there are many complex systems that can have alternative stable states that have tipping points. So that applies to these positive ones as well as the natural Earth system tipping points, and many of the same concepts and methods, or not methods, sorry, but certainly the same concepts applies to study both. And of course, there are also quite important differences as well, including that positive tipping points, they inhabit quite different domains. And so the domains that we have categorized these positive tipping points into are technological domains, which are the most commonly studied ones at the moment, where you've got the exponential take-up of renewable energy systems, for example. We have economic domains of markets and finance. There are possibilities to tip systems in a beneficial way in those. We have the social behavioral domains, which includes obviously social norms, values, lifestyles, cultures. And we also have a political domain, because for every success story that you get, whether it's the transition to electric cars in Norway, or the wind energy revolution in Denmark, or even things like the recent election in Ecuador that where people banned the mining of or the extract of oil in the Amazon rainforest. These things, all these success stories, they've usually got a political backstory. They don't just happen. So there are political elements to just about every rapid transition like that. So this is the way we categorize these things, and the conceptual framework is a key to understanding how we think about tipping points. And so it's all about the balance of feedbacks. If you think about oh, there is a nice chair here. I won't sit on it, but remember when you were a kid and your mum told you not to go back on the chair. Well, imagine a stable system state where the balance of forces is in favor of that chair going back into its previous state. So in that sense, the balance of feedbacks, I should use this here, is favoring the dampening feedbacks, or the negative feedbacks which try to keep the system in its present state. But once you get towards this tipping point, which is this dotted line here, then you're kind of up on the balance, where a small change now can make quite a big difference. So a small change could take you back to the previous state, but it's actually quite easy at that point then to tip it the other way. So you've got a transformation into a very different alternative system state. That's the tipping point. And after the tipping point, then the balance is in favor of these reinforcing or self-propelling feedbacks, which accelerate the system into its new state, ideally to a safe and just system state. But there are other possible alternative outcomes, including shallower or less desirable outcomes. And in the worst case, you get unintended consequences and negative outcomes, despite the theory that you would be desiring positive outcomes. So to encourage the desired outcome, we as agents can strategically intervene and to leverage change, but only during this enabling phase. And we can provide various interventions to help to get to that point where a transformational change can be triggered. So such as, for example, by making the desired, let's say, technology or behavior the most affordable, the most attractive, the most accessible, the most convenient, or the most morally acceptable option. Do I do this again? Oh, here we go. So one of the kinds of interventions, we have 5 kinds of cross-cutting enablers or interventions. The first being social behavioral interventions, such as community and network building, and that can shift these social norms and create things like social movements for change. There are also political systems, and these are interventions that recognize that changes in policy, as I just mentioned, often require firstly the recognition of the problem, and then followed by the building of a political coalition that then becomes a policy advocacy coalition that leads to policy implementation and action. So it's a sequence of events that enables that positive tipping point to happen. Change isn't just triggered, as I said before, by something. It's usually a result of quite a long struggle. We also looked at financial systems. So financial systems have got a pretty central role in influencing purchasing, investment, and capital allocation decisions, and they're influenced by a lot of different kinds of positive feedback mechanisms, as we explain here. The fourth kind is the digitalization we looked at, which has a really important enabling role to transform society in many different sectors, from teleworking to mobility as a service to smart homes. And it's important also to understand and try to neutralize the dampening feedbacks that can hinder the positive tipping point in these systems. And finally, if you remember, we talked in all of the previous sections about early warning signals. We've kind of adapted that. Josh, who just spoke earlier, Josh Buxton and Chris Bolton, wrote a wonderful chapter where we've taken this idea of early warning signals and we've changed it into early opportunity indicators, because these are things which might soon enable us or help us to measure our progress towards approaching tipping points. And it uses similar methods to those early warning signals in Earth systems. And the graph here is a data output from a change in people's preferences for electric vehicles over internal combustion engine vehicles by recording the increase in the auto-lag correlation and the variance of people's online viewing habits. And essentially it detects change in the resilience of a system. And as you get nearer that tipping point, it loses resilience. So finally, we looked at these various case studies in energy, mobility, and transport and food systems. And it's important to point out that some positive tipping points have already been crossed in the exponential take-up of solar and wind power and leading markets for electric vehicles. There's over 80% of new electricity generation in 2022 was solar and wind. So this is a tipping point that's well underway. The technology is also being developed to replace meat with alternative proteins. That hasn't happened yet, but it could be quite close. And then there's the great potential to transform the fertilizer industry by using a blend of green ammonia. Lots of potential uses for hydrogen, of course. And let's hope that in the wealthier segments of the population, we can one day make a breakthrough in our social norms and values. And so we can rid ourselves of addiction to consumption, overconsumption, and things like that, and prioritize the longer term and our children's futures. That would be a more difficult habit to break, perhaps. So one positive tipping point can help to trigger others. And here we get back to this idea of cascades, which we again develop as a positive approach. And so this is the idea that we can create this domino effect of cascading change. For example, as renewable power generation boosts the development of battery technology, better, cheaper batteries can then catalyze other sectors like road transport. And finally, following last year's breakthrough effect report, which I strongly recommend that you also read, we also talk about the idea of having super leverage points. I should go back actually one.
Click the opposite one.
Sorry, yeah. The idea of super leverage points, which are places to intervene to trigger positive tipping cascades, not just from one technology to the other, but also across these social, behavioral, and political and financial system domains as well. So the recommendations, basically that we need a really comprehensive and systematic and transdisciplinary research agenda. It's quite an early field. As I said, there's a lot to do. Decision makers need to think about decisions, about systems thinking in understanding how to create these positive tipping points. And one of the things that we understand about how diplomacy and policy advancement works is that sometimes small group coalitions are much better than trying to persuade, all the nations of the world to make a decision on something all at the same time. So by thinking in systems, we can create these catalyze change through using small group coalitions. There's thanks to over 200 people who took part in this report and authored it from 90 different organizations in 26 countries. So a huge debt of thanks to all of those. And also thanks to our report partners, the Earth Commission, Systems Change Lab, System IQ, and also the partnership of the Bezos Earth Fund. So that's it. Thank you very much. We've still got 10 minutes for questions.
So people online, if you want to post your questions in the chat, and we'll be looking out for them. If anybody in the room has a question as well. Mike at the back. Oh yeah, that's probably helpful. I can oh yeah, excellent. Good man. Thank you.
Oh yeah, thanks. I was just wondering about that kind of feedback network you showed in the positive and the negative points. And I was wondering, to fully understand it, you need to be able to quantify all of those arrows, right? But it seems like it's such a complex system. Like, what's the thinking, or how should we think about how we try and quantify those arrows? It seems really complicated. I don't really know how to do that. That's my first question. Second question was on you touched on it right at the end about agriculture, and I feel like that feels like because I feel like transport's kind of happening right with the electric vehicles, but agriculture seems to be the one that's lagging behind. I was wondering what are the big things we can do there.
Cool, yeah. I mean, I can take the first one. Well, I can try and take the first one. Yeah, quantifying the feedbacks is really difficult. I would say for some of the physical climate stuff, it is more obvious that those are the feedbacks that we would expect. For some of the more social positive input stuff, some of them are clear that the feedbacks would be there. Some of the tech development stuff, there's always questions, for example, in terms of like cost curves, what the strength of the feedbacks are in terms of production versus cost change. And some people would say that there is like a ballpark figure that you might expect between ranges, but not you can't necessarily put it down to you wouldn't be able to predict it necessarily for specific technology. Tom, did you want to say? Would-
Do you want to line me in it for the food system?
I was going to put Tom.
Give,
Red data, right?
this is
You-
Tom Powell
Yeah.
can answer the food systems.
Sorry, Mike, did you want to?
No.
Yeah, thanks, Mike. Just briefly on food systems. I mean, food systems are enormous and complex in their own right. So when we looked at food systems in the report, we looked at three potential kind of tipping domains. One is in demand, like dietary demand and dietary trends, where, you know, it's very clear that the livestock consumption drives the majority of the negative impacts of agriculture. And if we're going to make a substantive difference in our agricultural relationship with earth systems, changing livestock consumption has to be a part of that. There are strong, really, I mean, it's very complex. It's not quite the same thing as something like a choice of car, where if you have an electric car that performs as well as a petrol car and is cheaper, if you're going to buy an electric car, there are very strong kind of values and norms around food choices, and it's very entangled with other parts of our lives. I'm not convinced that there's some kind of clean cut tipping point exists there, but we are seeing quite rapid changes in norms around diets in really important places. So there was a Lancet report a couple of years ago now that showed something like a 17%. Sorry,
Yeah, the mic might not be
Mike.
very good, so
Mic.
I ask you to speak up a bit.
Okay, sorry. So I think that, yeah, a Lancet report that looked at English, UK dietary trends a couple of years ago found over the last decade or 15 years, there was something like a 17% reduction in consumption of livestock products on average in the UK. That's a really strong norm shift. It might not be that you remove them from the diet completely, but it's a powerful change. But we also looked, I think, really importantly at food waste, food loss and waste, and the kind of digital platforms that are emerging for combating food loss and waste and changes in supply chains, and also at farming practice. So can you transition to alternative farming models that have more circularity and more based on ecological principles that are less damaging in the, you know, on the 40% of the productive land area of the planet that farming occupies. And there's really powerful feedbacks there too. I think Ben Henneke is in the audience, who's really involved in one particular network in East Africa, where we look at really some social, environmental and ecological feedbacks in smallholder farming context, which have really powerful results and looks like a social tipping point for adoption of agroforestry networks.
We have some questions online. So Peter, you've got your hand up. Do you want to say your question?
Yeah, thanks, Josh. Just to say, fabulous stuff, folks. I'm having worked on the IPCC report that takes 7 years to produce. It's amazing you could do this in such a short time, relatively. So brilliant job, all of you. I just posed a question here. I mean, this thing about cascades, as you probably know, I think it's overstated a bit in the Earth system, because some aspects of the cascades involve very slow tipping points like Greenland melt, and Paul Rich is an absolute expert on this. But I think cascades are extremely relevant in the human realm. In fact, cascades are almost what defines changes in social norms, I think. And the trick of this is, or the irony is, that we probably can imagine cascades to a much better world quite rapidly in the human realm because of cascades. But we probably at the moment won't get reliable early warning indicators of when the sort of input that Steve was talking about would be appropriate. And that's basically because in strongly forced systems, the sort of critical slowing down precursors don't work so well. I wonder if you had any thoughts about that and how we might resolve it.
Yeah, I don't necessarily have thoughts on how we resolve it. I know we have thought about this a fair bit. Chris Bolton, who's also in the online audience, and I have thought about this a bit. I think some of the issues that we've also had is that for a lot of these systems, people don't collect data until something is already happening. So there's the data is really poorly temporally resolved before it tips, so you can't measure anything. And then you have other systems like financial systems where it's very data rich, and you do see abrupt transitions. But the literature is there's a lot of arguments as to whether you do see early warning signals, and some people think it is just a question of having the right resolution of data. But in terms of the strongly forced systems, I'm not sure that we would necessarily be able to resolve it. And some of these, some of the tipping points are very strongly policy driven as well. So there's potentially not necessarily the right feedbacks. So you see, ramp up people for example, there's certain policies that lead people to install things with an exponential growth, but it is basically just people rushing right before the deadline, whereby the policy will run out. So I don't think, the data isn't really right for those examples.
Okay, thanks, Josh.
There is another question online from Chris Langdon. How are we going to sit this into the policy process in UK to engage and enlighten policymakers in what is an election year? Yeah.
I hope people online can hear that question.
Well, yeah,
They
they
can
can
see
see
it
it in the chat. I don't have. Well, I mean, Tim Lenton's in the audience and maybe has a better idea for the strategic style implementation.
Yeah, well, our friend Laurie Laybourne is at least standing as a Labour candidate in, is it the Central Devon constituency, folks? So at least we've got one of our own. Depending on where we live, we might vote for. But I mean, I think, well, what to say? What was it last week or the week before that the opposition, the Labour Party, was rowing back on its kind of quasi Green New Deal, £28 billion or whatever? That's shocking in my view, disappointing, but presumably they need to feel a stronger mandate from the masses to have the confidence to push ahead with what I thought was a really positive, progressive policy. So God knows we're well off the topic of the seminar here, but somehow we've all got to signal at least as citizens if we believe in those things. What more to say?
Yeah, I would say, Chris, there's plans to do more policy facing stuff with the work, and some of the research gaps in section 2 in terms of impacts clearly have very policy relevant. But I think that's kind of a conversation we're having as a group while we're trying to map out the future of this community that we've built and what things we want to do over the next couple of years. So yeah, definitely welcome your input in that in the future, Chris.
Yeah, just pick on what Tim said. Yeah, engage with policymakers at all levels, including at local levels, I would say, because there's probably more that can be done by small groups of people. Yeah, obviously, yeah, vote for the MP that you want, and so on. Write to your MP. Don't just vote. Your supply of democracy is not just like, we're ticking a box, crossing the box every few years. Write to your MP, but invite to your local councillor. All these things we can engage a lot, and people in this room, we actually have the credibility of being academics in this area. We actually can have quite an impact, I've discovered, acting as citizens, but with our background in what we do. So get on and do it. We can make a difference, I think. So at all levels of governance. Yeah.
Excellent. Thank you. Okay, we've got maybe 1 or 2 more minutes. Does anybody have any other questions? We have one more question. We'll take one more question in the room, and then if anybody's posted a question online that I haven't seen and you want to restate it, please do.
Yeah, I had 2 very quick questions. The first one is, I heard quite a lot of talk about things like energy, transport, farming, resource extraction, kind of by extension. Didn't hear much about manufacturing processes, and I was just wondering if there was any kind of research you guys did on whether there be tipping points or things that could be done around improving manufacturing processes, reducing emissions, especially since a lot of the technologies that will be involved in other areas, in improving other areas, will involve lots of manufacturing. And then the second question was about I come from a kind of my area of interest is politics, and I think societal values. And it was interesting talking about systems within societies and values, but obviously there's a big boundary between cultures and countries and languages. I wondered if you looked into how, for example, you can cross some of these boundaries when you're trying to affect change on a larger scale. So, okay.
You want to cover the first one, Tom, and I'll cover the second one.
Yeah, thanks.
Could you pass them out to Tom?
Thanks. Yeah, I mean, in terms of manufacturing processes, like across all sections of the report here, we have to be really careful how we distinguish between things that we think are tipping processes and things that are improvements, but that don't display these kind of exponential dynamics. So we're really interested in transitions where we can identify these really strong feedbacks that can drive accelerating and self-propelling change. There are some really important rules that underpin those in the positive tipping points, and economies of scale is actually one of the most important feedbacks that drives things like cost reductions in production of solar panels or electric vehicles or whatever. So in those terms, we think to some extent about manufacturing processes, but in terms of the footprint of manufacturing processes themselves, I'm not sure we've thought enough about whether those kind of feedbacks exist in reducing manufacturing footprints. Just very quickly, I will hand over to Steve on the sort of crossing boundaries. I would say there's a kind of that sentiment runs in both directions. So some of these feedbacks we might think of as kind of universal, the kind of broad categories of things like social acceptability, the economic decision framings for people's decisions and positive tipping points. Those things exist in all societies, but might interplay differently in different societal contexts. And the solutions that we believe exist as positive tipping points particularly in industrialized, relatively homogenized Western societies might not always be appropriate in different contexts, different countries. So electric vehicles came up as quite a contentious issue early on in the report because, if you're looking at a country in sub-Saharan Africa where you don't have a functioning grid, or even in South Africa where you have, rolling blackouts every day that people experience, a car that relies on being plugged in isn't necessarily the best solution.
Just very quickly on the political situation. I mean, there's obviously certain universal things that you can work on, such as the sort of percentage of the population at which things tend to take off. There's some work been done by people like Erica Chenoweth and Damon Centola on that sort of how you create that S curve of exponential takeoff of political movements. But there are also, as you've mentioned, cultural differences as well that you have to take account of as well.
And then we've got time for one very quick question online. So Alessandra, I believe you have your hand up. Oh, you're currently on mute.
Thank you very much. I'm thinking about, it's a big electoral year, including the US, and we know that the US is very anti environmental policies. So I wonder really the impact of the geopolitical environment on enabling the positive tipping points at the global level. And I wonder if any of you has any thoughts.
Yeah, I've got the microphone, so I can go if you like to.
I don't know if it's working that loud. You can come up and stand at the front.
Okay, yeah.
Use them.
Yeah, I mean, so we think the geopolitical environment certainly interacts quite strongly with some of these important feedbacks. And, Femke, who's in the room, has done really interesting modeling work on the power of coordinating things like electric vehicle mandates between these sort of globally significant marketplaces. So if the key markets like the US and China and Europe coordinated mandates for EVs, you could bring forward a tipping point by many, many years. And clearly, for some of the production systems of these global technologies on which we're sort of pinning our hopes, there are global supply chains for those. There have been kind of complicated development pathways involving, collaboration between multiple different nations. So the geopolitical climate is very important, and there's certainly a risk that some of these key feedbacks could be weakened if the US and China have radically different approaches in a year or two's time.
All right, I think we'll wrap up there then. Thank you very much, everybody, for attending. To those online, it has been recorded, and I know people have asked if they'll be shared in the future. So the recording will be put on YouTube. There is another GSI seminar coming up in, is it next week or the week after that you're giving?
I don't think we have a date for it.
Okay.
Page one.
Okay, there's another GSI seminar coming up in the near future about another report that was produced at the university for COP. So thank you very much, everyone, for attending. There's also talk about doing another event on the Tipping Points report as more of a discussion. So if anybody is interested to get involved, please let us know. And then for those who are in the room, I believe Rich Betts will be leading us to the pub if anybody wants to come for a drink. So, thank you.
Which pub should we go to, Tom?
Which pub?
Yeah. What do you think? Turk's Head. Turk's Head, Tim. in town. Okay, we'll be going to the Turk's Head, everybody. Thank you.